Imagine a time when all the continents we know today were one, a supercontinent called Pangaea. This massive landmass, home to the earliest forms of life, existed about 335 million years ago, a time when dinosaurs roamed and our human ancestors were but a distant possibility. But wasn't destined to stay whole. Around 200 million years ago, it began to break apart, its pieces slowly drifting away from each other. This was the birth of continents, an epical event that would forever change the face of our planet. One of these pieces was the supercontinent Gondwana, a vast landmass that included parts of what are now South America, Africa, Antarctica, Australia, and yes, India. Right there, nestled within the heart of Gondwana, was the Indian Plate, a chunk of Earth's crust and upper mantle. But even as Gondwana thrived, the seeds of its disintegration were being sown. Forces beneath the Earth's surface were at work, creating and pressures that would eventually lead to Gondwana's breakup around 180 million years ago. As Gondwana split, the Indian Plate began its own journey, breaking free from its parent landmass and setting course for a solitary drift across the ancient Tethys Ocean. The Indian Plate began its long, lonely trek, carrying with it a wealth of flora and fauna, shaping and being shaped by the forces of nature. This was a journey of over 90 million years, a journey that would culminate in a monumental event that would forever change the face of our planet. As the Indian Plate began journey, the stage was set for a collision that would reshape the world. This was the birth of continents, a story of movement and change, of destruction and creation. And it's a story that's still unfolding, right beneath our feet. Setting sail on a sea of magma, the Indian Plate embarked on a journey that would drastically alter the face of the Earth. This voyage wasn't just an aimless drift. It was a mission. Propelled by the convective currents in the Earth's mantle, the Indian Plate set off on a northward journey. At a speed of approximately 20 centimeters a year, which might not sound much, but is rapid in geological terms, it was like a determined tortoise in a race against time. As the Indian Plate moved, it carved its path across the Tethys Ocean. This vast oceanic realm, once separating the land masses of Gondwana and Laurasia, was witnessing a phenomenal event unfold. The Indian Plate, akin to a ship on a voyage, was ploughing through the oceanic crust, leaving behind a wake of submerged land and marine life. The journey wasn't smooth sailing, though. There were times when it might have slowed down, and times when it sped up, but it never stopped. As the Indian Plate moved, it wasn't just changing its own position. It was also causing the Tethys Ocean to shrink, bringing Gondwana and Laurasia closer together. This was an unstoppable force, defying the vast expanse of the ocean and the immense pressures of the Earth's crust. And all the while, the Indian Plate was getting closer and closer to its final destination. You might be wondering, where was this relentless traveler heading? The answer is straight towards the Eurasian Plate. The Indian Plate was on a course, heading straight for the Eurasian Plate. A monumental event was on the horizon, an event that would not only reshape the geography of the region, but would also have far-reaching climatic and ecological impacts. But that's a story for our next scene. After millions of years of travel, the inevitable occurred. A monumental collision. The Indian Plate, moving at a speed that would put even a Ferrari to shame, finally met its match in the Eurasian Plate. This wasn't a casual bump or a minor scrape, but a full-on, head-on crash. A titanic clash of geological proportions. Imagine two cars colliding, but on a scale millions of times larger and over a timeline that spans millions of years. The force of this collision was so immense, so powerful, that it caused the land to crumple and rise, like a sheet of paper being scrunched up. This crumpling and rising resulted in the birth of the majestic Himalayan mountain range and the expansive Tibetan plateau. But the impact of this collision was not just limited to the creation of some of the world's highest peaks. It also brought about significant climatic and ecological changes. The towering Himalayas acted as a barrier, blocking the flow of air and altering the patterns of monsoons. This, in turn, contributed to the transformation of the ecology, fostering the growth of lush, dense forests and a rich diversity of wildlife. The collision also led a massive release of carbon dioxide into the atmosphere, triggering a series of global warming events. This warmed the Earth's climate, leading to the extinction of many species, but also paving the way for the evolution and diversification of new life forms. The Indian Plate continues to push against the Eurasian Plate, a stark reminder of the dynamic nature of our planet. So the story of the Indian Plate's collision with the Eurasian Plate is not just a tale of two continents. It's a saga of creation and destruction, of evolution and extinction, of climate change and biodiversity. It's a testament to the incredible power of nature and the intricate processes that shape our world. The collision was not a single event, but a process that continues to shape our world today. To understand the past, scientists turn to the evidence etched in the rocks beneath our feet. As we delve deeper into the ground, we begin to unravel the mysteries of our planet's past. The geological story of India's collision with Asia is no different. The geological evidence supporting this fascinating tale is found in the rock formations and fossil records. These are like the pages of Earth's history book, revealing the secrets of the past. It's as if Mother Nature, in her own cryptic way, has left us clues about the dynamic journey our has undertaken. Take, for instance, the rocks of our Earth. They are composed of various types of stones, including gneiss, granite and marble, each telling a different chapter in the story of our planet's development. Beyond the rocks, scientists also study fossil records. These ancient remnants of life provide a snapshot of the Earth's past ecosystems. Fossils found in different locations narrate tales of varying landscapes, some even revealing that certain lands were once at the bottom of the ocean. It's a surreal thought, isn't it? That lands now brimming with life were once submerged beneath the sea. To uncover these hidden facts, geologists and paleontologists work tirelessly, studying the Indian subcontinent's collision with Asia. Their research provides us with invaluable shedding light on the massive geological changes that our planet has undergone. And their work continues, as the Earth never ceases to evolve. These insights from the past serve as a guide to the future, helping us understand and predict geological events. The study of plate tectonics, for instance, can help us anticipate earthquakes, informing our preparedness for such natural disasters. The rocks tell a tale of a world in constant motion, of continents colliding. Through the study of rock formations and fossil records, we get a glimpse into the Earth's dynamic past, and perhaps a peek into its future. In the grand scheme of Earth's history, the India-Asia collision is a recent event with far-reaching effects. In one breathtaking geological moment, the face of our planet was forever changed. But why does this matter? Why should we care about a colossal event that happened millions of years ago? Understanding plate tectonics, the science behind the India-Asia collision, is like having a time machine. It allows us to venture back to the days when Pangaea was whole and dinosaurs roamed the Earth. It lets us witness breakup of Pangaea, the drift of the Indian Plate, and its monumental collision with Asia. This knowledge isn't just a journey into the past, also a glimpse into the future. With it, we can anticipate how the Earth's crust might continue to shift and evolve. Plate tectonics isn't just about the past and the future. It's also about the present. The India-Asia collision didn't just create the Himalayas and the Tibetan Plateau. It's a reminder of the incredible power and dynamism of our planet. The India-Asia collision is a testament to the fact that the Earth is not a static sphere, but a living, breathing entity that is constantly changing and evolving. It's a story of how even the solid ground beneath our feet is in a state of perpetual motion. As we delve into the mysteries of tectonics, we also delve into the story of our planet and our place within it. We learn to see the Earth not just as a backdrop, but as a dynamic actor in its own right. As we stand on shoulders of this geological legacy, we gain a new perspective of our ever-changing world.